Hello, my name is Byron Serrano, and today I'll be presenting my Advanced Maths and AI coursework. This specific video will be based on question 4, the generating content. As you can see here, I have my grid generator. As this is part of the script, I made this public so I can edit it through the Unity program. Now, when I press play, this normally takes a while because what it's doing is uh, it's spawning a bunch of assets on on random locations. And what it does is once the cluster points are placed in, it will try find if they have one of each in that specific section. And if it doesn't, it destroys all the assets and prints them back out. And it constantly does that until it finds it's the cluster. It checks if it has one of each, and once it does that, then it loads in the game. So as this loads, I can explain here. Here we have the grid size. It's 20 by 20. The segment again is just a prefab of the cube. You go here the noise scale, which is practically the height of the noise, the purling noise, and I've set a specific cutoff point. The cutoff point is 5, just to any of the noise that would reach a specific 5 would drop down to 1, so that would be the floor, and anything above 5 would practically be the walls, and that's the main concept of um, setting up the room. So that again, like I said, the cutoff point, what that does is I'm just adding a specific filter to just smoothen out the terrain. Now here we have all the items. Again, we have six items, five different items. One, two, three, four, five, six. Yes, 6 different items. Categorized into 4 different categories. So obviously, on the brief it said spawning 8 assets, but how I have it is that it randomizes. It's got a percentage of the likeliness of spawning. So obviously, uh, in the game itself, it can spawn as over 8. So it could spawn just above 8. It's just depending on the percentage, the likeliness of it. So now, as I can see here, let me explain the concept of my game. The concept of my game is supposed to be based on you're working in the laboratory and some of the test subjects escape the lab rats and mess up the laboratory. So you have to go through the laboratory, collecting the resources and collecting up the rats. As you can see, you have here you have the 4 different categories. You have a test tube. You have a bio waste, the rat, and an environment. As you can see here, this is a different colored test tube. As you can see, you can walk into them and collect them. You got the test tubes, the rats. You can go around and collect them. As you can see here, this is another different asset. It's still part of the bio asset category, so uh, it will still be categorized. As you can see, that the test tube was red. Again, those are just different assets, but they're all categorized using the cluster points. As you can see here, this is also the asset of the environmental. So here is you just collide against it. You can't actually pick it up. So again, the rest of the assets are here. As you can see, here is the Pathfinder. Also, this Pathfinder, I just set it as a specific coordinate. So when you place in the specific coordinate, it will check if it has if the coordinate's not a wall, and if it is, it'll spawn the Pathfinders. And again, here is the specific coordinate point I have placed. Now, if I stop this and I move on to the code side of this, here I made most of my functions in the grid generator class. Now, as you can see here here's where it creates the grid itself. So what it does is it takes in the x and the y size. So what I mentioned before, I set it as 20 by 20. So it creates a new grid section. And then um, here it creates the grid or the terrain. It goes through the x and y, or loops through the x and y, and what it does is it creates the grid section, and by spawning the prefab, which the prefab was the cube, and then after that, after it creates the 20 by 20 terrain, what it does is it goes, I've set it up so I can create a wall, and what I've done is I've gone through the x and the y and minus that to create a border, and I've made that as the walls. And then what that does is after it creates the walls, it obviously names it wall and it makes it true, because down here, what it does is it creates, it gives the walls a different color, a different material texture, so you can differentiate between the walls and the floor. Now, here's where I did the specific cutoff point. What I did is it loops through the purlin noise, like I was mentioning before, and the cutoff point as I have it up here. So as 5, anything below 5 will be placed will be as 1, and this is mainly just to smooth out the terrain, just to make it look less less wavy. So that's what I managed to do there, and that's creating the terrain part. Now here, we have, again, this is here's where it uses the purlin noise. So here's where it actually creates and returns the purlin noise texture. So what it does is it loops through the each pixels of the texture, creating noise based on the maths function, and that's how it creates the room. Now this is the spawning the objects. Now how I have it here is like I mentioned here. Here you have the 6 different assets, and what I have it looping through the x and the y's grid, and what it does is if it checks if it's a wall or a floor. If it's a wall, then you can't spawn, you won't be able to spawn the object there. If it's the floor, what it will do is it will check if it's reachable here. Here it will use the Pathfinder. Again, the Pathfinder, we used the A-star code we learned through the tutorials, and it will check if you can reach that specific point. If it's closed off, then it wouldn't spawn anything there, and if it isn't closed off, then it would move on to the next section, and what it would do is it will give it I made it a 5% chance of spawning. Now, if it lands in that 5% chance, it will go through here, and what it'll do is there's a 20% chance of one of, oh, well, not 20% chance. It's a 1 in 6 chance that one of these items have it. Any of these items spawn in them, and yes, so it will check. It will have a 1 in 6 chance, and it will spawn an asset there. Then here we have this is the clustering section of it. So what it will do is it will create the cluster, and what it will do is it will check this section here. It will check if it will run the check one of each function, which is in this section here in the k-means class. Now here what it does is here it just it prints out the information on the console to see to check if the clusters has categorized them. Now here what it does is it checks each asset has a specific tag, and obviously because the requirements were 4 categories, I have done these 4 different categories as test tube, environment, the rats, and the bio assets. And what it does is, as I spoke about it in this section here, when they print out specific points, so when it prints out the assets through the percentage, the likeliness of it spawning, when it creates the cluster points, it would look and check if it has one of each through this, it'll call out this function. And then here it will check if it has one of each. And if it does, then it will run the program. But if it doesn't, it will go through here. And then practically what it does is if it checks if the function, the check one of each function works. If it does, then it'll print it. If it doesn't, it will destroy all the assets and rerun the the spawning of the assets until it meets the criteria of checking one of each. Now, on regards to yes, let me just double check that I haven't missed anything out. But separate to the main course, sorry, the main assignments. Obviously, you can check here that I've done. Here's where I have it checks if it is a test tube or rat or bio asset, which the player would be collecting. So what it does is if it checks if it does and if it collides, and if it does, it will destroy the asset. So it seems that the player has picked up the asset. Now, just to run quickly through the generating the terrain. It's here, and oh yeah, just this is the last bit I forgot. So what this does is this is where it just prints out. Again, it uses the A star functions. Sorry, the A star class, generating the paths. And what it does is, as you can see here, you set a target, the X and the Y, and once you do that, it just prints the path, and it checks if it's available, and if it is, then it will print the path out, and that's how you can see it in the as you saw it in as the green flow. Now that should be all on regards to question 4. Just a quick rundown of question 1 and 3. I'm not too sure if it's required on this video, but as you can see here, if I run the scene and I go to consoles, what this does is it goes through what it does is it checks through the variable matrix that we've taken. So let me just open the script up here. So what we used is what I did was what I learned through the tutorials using the decomposition and do list. What this has done is it's used the matrices provided, and it goes through the do list algorithm, and then it prints onto the console, and it finds out what A matrix is, the L and the U and the X, and here's the decomposition of the algorithm. Now for question 3, you can see since here, open here, question 3 here. Now this code uses vertex 3, and what it's doing, it's working out what the x, y, and z of the equation are. Now if I run this, what it does is once it figures that out, it adds it to the string and prints it out on the console screen. Now here's what it printed out was all of the whole simulation. Now the first part of question 3, it asks, do the paths do the particles collide? Now with this working out, it shows that the paths do intersect, but not at the same time. So do the particles collide? It would be a no, the particles did not collide. Thank you for watching my video.